I am starting the stream. Let me know if you guys can see it.
There's going to be a little bit of a delay, so.
Yeah.
Well, it's already streaming.
Okay, lovely.
Okay, hang on. I'm gonna reload.
I'm reloading.
Oh.
All right. So I think, Zena,
All right.
you can do the intro. Go for it.
Hello, everybody. Here's Starry Night Live. We have Zena
And Kyle.
And Beatrix.
And Malcolm.
Woo,
And-
welcome.
and Susanna from Rask.
Yes, and Susanna from Rask as well. So yes, thank you, Zena, and welcome everyone to our impromptu online Starry Nights. Yeah, because of the weather, it is a crisp 263 degrees out there. So our equipment, just keep in mind, as we were setting up earlier, our equipment has been a little bit laggy, knock on wood. So everything seems to be working fine so far, but please forgive us if maybe some things are unresponsive or things like that, that we're working on it. And it's unexpectedly got cold in the last couple of days. But for those that are kind of a little confused, 263 degrees is on the Kelvin scale. So it is -10. I mean, it's probably gotten colder over the course of the night, but last time I checked, it was -10, -11 degrees Celsius out there, which corresponds to 263 degrees Kelvin. So anyway, thought that was kind of cool to get started. But anyway, yes. Do you want to say anything to start, Zena?
Yeah, I guess we can. I was thinking, this is the first time you and I are co-hosting, Kyle. I usually co-host either with Matthew or Abby, but this is the first time we're doing it. Isn't it interesting? It wasn't even planned. It just happened. And you and I are both teachers. I just realized that we're both high school teachers.
Yes, holy smokes. Yeah, it's kind of funny how life kind of works out that way. Yeah. But I'm excited to host with you, Zena, and I think this is going to be a great lineup that we got going on. But I mean, hey, we're both teachers, so maybe I'll talk about how I got interested in becoming a teacher and how I got here in the first place. And maybe we'll actually go around introducing ourselves, Zena and myself, as well as Beatrix and Matthew. We'll just give a short introduction on how we got here in the first place. But for me, my journey began back when I was about, I think it was 7 years old. And I was actually visiting my grandparents in Nova Scotia. And one night, my mom just kind of said, hey, let's go see your cousin's grandfather, Reggie. He just lives about 20 minutes just out of the little town of Truro, where my grandparents are from. And he built his own observatory in his backyard, which was really, really cool. So being a little seven-year-old, I was kind of saying, okay, sure, let's do it. So we went out there, and it was the clearest sky I have ever seen. And there was so many stars out there. We looked at Jupiter, we looked at Saturn, all sorts of things. But it was also the time of the Perseid meteor shower, which for those astronomers and our fellow astronomers in the chat and joining us, is an August meteor shower. So I saw a meteor shower for the first time, essentially. And from then on, I knew that I wanted to study this and I wanted to show people this as well. So I'm 29 now. So that is, 23 years. I was about 6 years old, not 7. 23 years that I've been doing this for, and it all started with just a little push from mom. So it's kind of
Aw.
funny how life kind of works out that way, where you never know where life is going to lead. And so I'm now a high school teacher in the Coquitlam district.
Oh, that's awesome. I like how
Yeah.
my story is kind of similar to yours. It's actually, I would say, parallel almost.
Mhm.
My story also started when I was very, very young. So I am actually from Iraq. So it
Okay.
started somewhere in my. It was actually with my dad. So one night, usually in Middle East, the nights are very clear and you can clearly see the Milky Way. So we have beautiful night skies. And when I was very young, I think I was in grade 5. No, that's not true. Sorry, grade 2. No, grade 3. Sorry, I'm mixing it up. So maybe in elementary, let's just say that.
One
And
of
I
those
was with
grades.
my dad one night and in my grandma's backyard, and we were looking at the night sky. We always have this bond where we just look at the stars, me and my dad.
Mhm.
And that one night I saw this star that had a tail, and it just looked so different from the other stars. I asked my dad, "What is this star with the tail?" My dad didn't know what was called. He knew it wasn't a star, but he didn't know what to call it. So he just said it's a star with a tail. And that's when my interest in astronomy sparked. It was a comet. It was the Hale-Bopp comet.
Whoa! Oh, that's awesome. Was it
Yeah,
a? So it was visible for the naked eye.
it was. It
Oh,
was like it was very clear. Very visible. And that's when I became very, very interested in astronomy. I even had the dream of becoming, an astronomer and join NASA. But then that ended with quantum mechanics. Once I got to quantum mechanics, that was over for me. I said,
oh,
okay,
fair enough.
I love the poetic side of astronomy. And then after that, I pursued research, masters, and then here I am, a high school teacher. And almost every year I teach astronomy with my students and I bring them to the observatory.
Nice,
So it's
nice.
like I'm fulfilling the dream. I get to teach the poetic side of astronomy.
That's so great. Oh God, Hale Bopp. That must have been so cool to see. I remember seeing my first great comet was Neowise, which I think was probably a lot of people's first comet. I remember going up to the Horizons uh, restaurant, and it was packed with people. But I could just imagine that Hale Bopp would have been incredible to see.
Oh, well, you can see it from the backyard. At least I remember it clearly. It was a star with a tail. It's like any other star, but just this one particular one had a tail.
Wow,
And you
that's
could see it
so
like
so cool.
changing position almost. Like every night it's in a
Oh,
different place.
oh, that's crazy. Okay, nice.
It was
All right, well, excellent.
it's like precious moment me and my dad had. Like
Oh,
once in a lifetime, literally.
mhm,
But who
that's
knows? There's
incredible.
also Halley's comment. Who knows? We might see it if we. I don't know if we live long.
If we live
I
long,
always
yeah,
tell my student, "You
absolutely.
guys will see it," but I don't know how old would I be if I were to see it. Probably in my
Mhm.
70s.
Yeah, yeah, me too. Excellent. Okay. And also just going to our moderators, Beatrix, how did you get here? What's your journey? Uh-oh.
I think maybe Beatrix will
Oh,
probably
she's
just
muted.
she's
Oh,
probably
okay.
just do it on the maybe the chat.
Oh, sure. Okay, well, maybe we'll bounce it over to Malcolm. If you like to share your journey, uh, go for it if you'd like.
Yeah, sorry. I'm just trying to remember how to spell something and failing miserably
Oh,
at it.
oh,
Hi
that's okay.
everyone. I'm Malcolm. I'm actually currently the back end for the stream. I have like two monitors of the stream. It looks really funny. Um, I've actually
Tech.
not been in astronomy for too long, which is kind of funny. I originally was, as a kid growing up, I was always into natural disasters. Like I loved them. I would literally go into libraries to find pictures of the most terrifying natural disasters on Earth. I was a weird kid.
Whoa.
And then when I got into high school specifically, in about grade, I can't remember if it was grade 9 or grade 10, I watched a movie. And this one movie completely changed my entire perception of the world. And you may have heard of it. It's a small indie movie called Interstellar. Um, it's about this dude who's played by Matthew McConaughey, and he gets into
All
a
right, all right, all right.
he gets into a Lincoln powered rocket ship and goes to planet Lincoln. Yeah, that's the story. Anyways, I fell in love with the concept of general relativity and time dilation, and I kind of thought to myself, there's probably nothing in the universe cooler than real life time travel. So yeah, I'm gonna do that. That's what I want to do. Yeah, and in I think first or second year of my time at college in Douglas College, I took an astronomy course. First year, and if you're in that, I'd recommend taking it. Um, First year astronomy course, and it was so neat because one of the topics we went over was neutron stars and how absolutely incredibly dense neutron stars are and how they completely just bend our perception of reality and how things work. And I kind of thought to myself, you know what? I know exactly what I want to do. And so right then and there, I basically said, I want to do stars. I want to study stars. And that's kind of how I got really into astronomy. And then I got to SFU and I heard, oh yeah, the observatory, where we're currently looking. So I immediately applied within like as soon as I heard that, basically, I immediately applied. And I'm so happy that I did. It's been pretty spectacular, actually, my experience here. I've honestly I've never regretted it once. Yeah. I'm quite happy I went to Canada.
Spectacular.
Great
Great.
story.
So Matthew McConaughey did it for you.
Yeah, Matthew
Yeah.
McConaughey.
It was Matthew McConaughey. There you
Yeah,
go.
it
And
was
it's
Matthew
so-
McConaughey.
Oh my God. And it's so crazy to think that this general relativity, time dilation, length contraction, are all real things.
Yeah.
And it's not just some magic. This is the code of the universe. Like it's crazy to think about this kind of stuff. Anyway.
Yeah, and it's cool though because if you think about it, if you were up at SFU right now, which none of us are because we're all nice and cozy at home, if you were up on the mountain at SFU, you would be aging faster than people on Earth. Like sorry, people lower down like in the city. So anybody in like downtown Burnaby or something like that, they would be aging at a different rate, slower, so to speak, than people up at SFU. And yes, as our lovely guest star Dr. Joanna Wu has pointed out, the star that we're currently looking at, I almost said the wrong name again, Betelgeuse is actually at some point going to become a neutron star.
Whoa!
Is it? Is it actually? Not a black hole?
I don't know. Actually, I don't think so. Do you,
Joanna?
Joanna might have to confirm that one. Yeah, because yes,
this is where our lovely moderators will step in and fact check us as we're speaking.
There's a bunch of ranges of masses where you get one or the other. It's really confusing.
Very nice. Well, how about let's talk about then so I guess since we have Betelgeuse or Betelgeuse, however you want to pronounce it, it's not the band, it's a red supergiant. So
yes.
So stars actually they go through phases and they age just like people do. So Betelgeuse is considered, it's almost at the end of its phase. I don't know. I guess stars don't really go through death. If anything, they just go through a cycle of just changing phases. And then, so I guess with the red supergiant, they're almost, especially for Betelgeuse, it's almost at the end of its phase to turn either into to go through a supernova and then turn into either a neutron star or a black hole. But you're saying, Malcolm's saying it's actually going to turn into a neutron star. So that's very, very cool. And one of the most, for me, that's I find mind blowing about Betelgeuse is that we might actually see this supernova within our lifetime. Or at least I hope so. I hope we would get to witness that phenomenon within our lifetime. Yeah, go ahead.
Well, I was going to say, because it's not very far away. Like, I think it's only about 400 light years away or something. And I think some strong evidence that it's close to the end of its life is it's going through these periods of brightening and dimming. So it's kind of like oscillating. And it's going to be, if and when it goes supernova, it's going to be as bright as the full moon, I think. So you can actually see this thing during the day too. It's going to be crazy when it blows up. One thing I do want to mention before we kind of move off of it, I'm just going to dim the exposure here to just illustrate another fact of our planet. Is this twinkling effect. A lot of stars go through this twinkling, and that is due to our atmosphere, pretty much. So you can see it kind of twinkling, and there's like a kaleidoscope of colors and rainbows and stuff, and that's because of our atmosphere. When light enters, our atmosphere acts like a prism and refracts the light. And refraction, we've seen refraction before when it's a rainy day and there's sun on the horizon. We get this nice, beautiful rainbow. So the water droplets split up the light into its component colors. Well, same thing happens for starlight. For our atmosphere, is when starlight enters, it gets refracted and we get this kaleidoscope of colors and this twinkling effect. So just to kind of mitigate that, especially for this star, I just turn up the exposure time here just a little bit, and you get this nice, pretty looking star.
Oh man! So all these years since I was a kid, I thought the stars twinkle. So all these Disney movies that talk about twinkling star are not true.
How I wonder what you are. Yeah.
So yeah,
Exactly.
so the I guess I don't know, would I call that a fun fact, but a fact is that stars do not twinkle; they twinkle in your eyes.
Mm-hmm. They twinkle before getting to your anyway.
Or before. Getting too specific.
In the atmosphere and stuff like that.
Exactly, or just in your head. I was gonna say they only twinkle in your head; they don't really twinkle.
Yeah, exactly. And again, unfortunately, I'm not keeping my eye on the chat, so I might even repeat some things that might be said in the comments down there. But I just want to mention that the size of Betelgeuse itself, if I remember correctly, it's about as big as Jupiter's orbit is big around the sun. It is a massive star.
Hence the word super red giant.
Super giant, exactly. So this is the ending stage of a star's life. And I think what we'll do now is maybe let's move into...
Oh, actually, before we move, so just, I guess, in comparison to our sun, so our sun will turn into a red giant, not a red supergiant. Because our sun is not massive enough to turn into a red supergiant. So if you were to go backwards, so Betelgeuse was probably a blue star, or so not a blue star, but a super massive star.
Mm-hmm.
I do think it would have actually been a blue star. Yes, I think you are correct, Zena.
Yeah, well, I don't know. Not sure. I guess the people in the older days will tell us. People who lived in the past can let us know.
Many millions of years ago.
Yeah.
Okay, so I think with that is Betelgeuse. Kind of a close object to our own sun, but let's move to maybe star cluster here. PL. There it is. Okay. Okay. Like this. Kind of a next door neighbor to Orion and to Taurus. This, by the way, this program's called the SkyX. This is what we use to control the telescope and how to move it around. So we were just at Betelgeuse in Orion. So we are going to move over to the Pleiades and have a look at what this star cluster has to offer.
Nice. The Pleiades is also known as the Seven Sisters.
Mm-hmm.
It's also that thing you see on Subaru cars.
Oh, I forgot about that. Yeah, Subaru cars, the logo is the Pleiades. That's really cool. Okay, so I'm zooming out a bit. So now let's...
I like the story, the Greek story behind the Seven Sisters. Because it talks, I don't remember the full story, but they were saying that, so the Orion is chasing the Seven Sisters, and the Seven Sisters are protected by Taurus. And the mind-blowing thing about this story is that they're saying because of the universe is expanding, the Orion will one day catch up to the Seven Sisters.
Oh, I see what you mean. Yes.
Or four sisters. Yeah.
Okay, so I just switched the exposure time over because we're looking at a deeper sky object, we need to take longer exposure times. Which is why I switched it to around 20 seconds, because that'll give us plenty of time to capture lots of light from the object. And now I'm just going to play around with the Instagram here to try and get as better view as I can. The thing with the Pleiades is it is an eye object, actually. You can see the Pleiades from, or with your naked eye, I should say. And like Zeta said, like you say, it's called the Seven Sisters because ancient astronomers looked at this object and they saw 7 stars. And because of that, it's
just a little thing. I'm sorry to cut you off, Kyle. Just a little thing about our camera is that our camera and our lens doesn't actually allow us to visibly see all of them at once because we see, like, our telescope is too powerful, I guess, so we can only see a certain amount at one time. We cannot see all of them, so if you're not seeing all 7, that would be why. Sorry to cut you off, Kyle.
Exactly. No, that's good. Yes, thank you. And we can see it from Earth with our own naked eyes, which means it's pretty darn close to us. This is where moderators can help me with fact checking. But I think it's 3,000 or 4,000 light years away, if I remember correctly. Anyway, so it's pretty close to Earth, and
it is about 444 light years.
That's what I said. Yes, thank you. 400 and how long? 44?
444. Yes.
Okay. So it is the closest star cluster to Earth, actually, which is really kind of cool. Yes, thank you for zooming in here.
Well, the thing that I like about that star, because like you said, like the ancient astronomers were able to see with the naked eyes, even we can. Like we have light pollution, and I am just amazed that even with the light pollution, we can actually see the Pleiades or the Seven Sisters. That just makes me think about back, like with the ancient astronomers, probably there wasn't as much light pollution. It was probably so fabulous and spectacular.
Oh, yeah. They might have been able to see 8 or 9 stars, maybe.
Possibly, yeah. And with this, I was thinking even maybe the colors. Maybe they could see the color. So the Pleiades are blue stars, and with stars having different colors, actually reflective of different temperature and age. So blue stars, which is kind of with blue stars are, you would probably think it's a cold star, but it's actually not true. In astronomy or in space world, it's the opposite. So blue stars are very, very hot, and red stars are cold. And and also
really?
with blue stars are also very young. So with
blue stars are very young. Okay.
They're considered young. They are considered young stars. So I think with what you were saying that so if I were to remember the Pleiades in particular, I think they are 100 million years in age, which is that's actually considered relatively. That's actually considered very young.
Yeah, 100 million years old. Yeah, that's pretty young in terms of astronomy. So that's pretty nice. Holy.
And for me, honestly, the most phenomenal thing about anything to do with astronomy or any celestial object is actually the concept of time. So for just taking the Pleiades, for example, so the Pleiades, you mentioned it's about 400 light years away. Let's just use a nice number. So that means we're looking at those stars, how they were 400 years ago. We're not seeing anything currently. We're seeing it in the past. And the reason why is because it takes that long for that light to get here to where we are, to reach our own eyes.
Holy smokes.
Isn't that mind-blowing?
That is crazy. And
here's another oh yeah, go ahead. Sorry. There is something else that I find crazy. So
go ahead.
With blue stars, because blue stars they because they're young, but they also die sooner, or they shift or change phase sooner. So we could be, when we're looking at the Pleiades, I keep thinking we're probably looking at the ghosts of those stars.
The ghosts. Oh yeah, they could, like some stars could be gone already.
So
and we just
have
don't
to
know
wait
about
400 years from now to find out.
It's funny you guys mentioned that. That is actually a pretty brought up statement that that the stars that we look at in our universe could actually already be dead, due to the fact that even the largest stars have a lifespan in terms of a few million years, or tens of millions of years, and all of the stars we will actually see ever in our night sky, with our naked eyes anyways, every single one of them is in our own galaxy, which means that they're only at most about 70,000 light years away. Every star you see in the night sky is more than likely still alive. It is still very likely that all of these stars are actually still alive, just because they are in our galaxy still. That's not to say that some of them might be, like for example, with things like Betelgeuse, which is almost dead, that one could very well already be dead. However, all the stars that don't appear to already be dead are probably still alive today.
Whoa. I guess that's just, whoops, wrong way. I guess that just goes to show that our galaxy is still pretty small compared to the rest of the. Whoa. Let me fix the histogram here. Get over there. Okay. Uh-oh. Okay, let me just.
Also, actually, with Pleiades is an open cluster. For those of you who are not familiar with those terms, so open cluster versus a globular cluster. So globular cluster, just from the term cluster, means is a cluster of stars. So globular cluster has thousands of stars clustering together, while with an open cluster you have a number of stars cluster, but it's not as many as a globular cluster. And the idea is that all the open cluster eventually will turn into a globular cluster, where all the stars are just gravitating towards each other to. Actually, I'm not sure what's happening once they gravitate. I'm not sure what's the reason why they gravitate. But I think there's some theories. Maybe it's a black hole, or maybe just the stars themselves are just attracting each other.
Mm-hmm. Well, I hear
And
it's still an active area of research, though, on
it
how
is.
they attract. Yeah.
And there's people who are, or astronomers who are interested in studying the age of the universe. They actually go study globular cluster, because globular cluster are one of the oldest objects in the universe that could reflect or they study them to reflect the age of the universe.
Mm-hmm.
Because they are, so globular clusters, I think the universe is 13.4 billion, sorry, 13.8 billion years, and
Mm-hmm.
those globular clusters could be in the billions of years. Can't think of a cluster.
Yeah. They
of a
form,
particular
like
age.
you said, I think, they form alongside their parent galaxies,
Mhm.
which is really kind of cool. Oh,
Yeah.
interesting. So, Pleiades. Okay, so that was the Pleiades. Very young star cluster, very close, and something you can see with the naked eye. And it's an introduction to how colors work in space, in terms of at least colors on stars. I think our next thing, let's put a little wrinkle in that. And let's turn to something a little more familiar. Let's go to the planet Uranus, which is still, everything's so close to each other. That's great.
Actually, I was thinking Orion's. Are we not close to Orion Nebula?
Well, we moved off to the Pleiades. Whoopsies. Yeah. Got our, whoops. Okay.
But yeah, you know what? Since we're talking about colors, let's
Live.
look at Uranus. Maybe we can see its blue color.
That one. Yes. It's because I need to switch this over to here. Go like this. Oop, wrong way.
You are still in live view, by the way.
Hmm?
Yeah, so because there it is.
Are you trying to
Because I
get?
want to.
Are you trying
Yeah.
to get
I'm
Uranus?
just trying to get. So I just got the live view. Actually, okay, Malcolm, do you think you can change that to 1 second or 1,000 milliseconds if you can?
Yep, I can do that.
The exposure time? Yeah.
I hope. Is it gonna let me?
Well, while Kyle's trying to get our planet, trying to find. Oh, you already did. Awesome.
Are
Good
you
job.
not
Yeah, it's
able
there.
to? Are you also not able to type?
I
Yeah,
can't
okay.
type. So
Yeah,
that's why
it's
I've been
it's being
scrolling.
weird. It's being weird right now, so that's fine. It's just doing its thing. It does this sometimes, so don't worry too much. And there goes the exposure. Okay, and we got to go back to 1,000 now.
So Uranus is actually the
There we go.
first planet that was discovered in the modern times. So I guess you can't really see it with the naked eyes or with just the regular telescope.
Yeah, no, it's pretty difficult to see with a regular telescope. So now what I'm going to do is I'm going to zoom in. So give me a couple seconds here. There it is. So what we have set up is we just have a live view of Uranus. Pretty much what's happening is the camera is taking pretty much 1 second exposures. and displaying it. And then as soon as another exposure comes in, it gets rid of the last one. So we kind of get like a live view of Uranus. Now, what's immediately striking is that it's blue in color.
Yeah.
Now, Zena, does that mean that Uranus is 8,000 degrees Celsius?
No.
No, exactly.
Was that a
Exactly.
trick question?
Oh, no. Well, just because we were just talking about how blue stars,
Yes.
even though they're blue in color, they're like 10,000 degrees Celsius. But cool stars are red. But here we have an example of a planet that's blue in color. And this is where we have to make the distinction that stars' color kind of operates differently than things that are much, much colder, like planets and asteroids and stuff. And that's because the atmospheres on planets. Oh, I'm sorry. Go ahead.
Oh, no. I'm agreeing with you.
Oh, okay. That's because the atmospheres on planets display color based on essentially chemistry and Rayleigh scattering, as it's called, at least for here on Earth. That's why the sky is blue here on Earth, is due to what's called Rayleigh scattering in the atmosphere. Where again, like we talked about at the beginning, that our atmosphere is refracting light that comes in, and essentially the blue color makes it through. Kind of, and this is again where moderators can help me out with this one. It's kind of the same principles for the gas giants that are out in space. Jupiter has lots of reds and yellows. Well, reds being the equatorial bands, the red-orange color, and yellows for the rest of its atmosphere due to its particular chemistry. Same with Saturn, Uranus, and Neptune.
And Mars.
And Mars, yeah. Mars's red color comes from the, I think it's iron that's in its surface. That gives it that red color.
So they say the skies are pink in Mars, on Mars.
Yeah. Oh, that's crazy. So yeah, it doesn't mean that Mars is, 3,000 degrees or something. It's just now we're dealing with chemistry that gives us different colors and spectroscopy. Or I'm sorry, no, not spectroscopy, just chemistry.
No, I understand. That's actually good. Wow, never thought about it from that perspective. That's actually a really great distinction, and it's great to bring it up. Because
okay. Oh yeah, go ahead.
Oh no, nothing. I'm just trying to think of any facts about Uranus. Like I know one of for Uranus, it's the tilt, because it's the one that rotates laying down in comparison to Earth. And I believe Uranus is the one it's rotating in it rotates counterclockwise. I believe.
Yeah, I believe so. Same as Venus. I think Venus and Uranus orbit in a retrograde.
Oh yes, that's right. Yeah, Venus as well. That's true. Forgot about that.
Yeah.
And so for Uranus is it orbits around the Earth every almost 80 years, or Earth years.
Oh yeah.
So 1 year on Earth is 80 years or 84 years on Uranus.
Yeah, no, it's crazy long for an orbit. And okay, and that brings this up as well, that speaking of crazy orbits, Pluto has not completed one orbit since its discovery as well by Mr. Tombaugh.
Oh, that is crazy. Wow.
I didn't know
that.
Yeah, no, it's awesome. Awesome in terms of how long it takes. Yeah, it's only completed about a quarter of its orbit since its discovery.
Wow. Just a quarter.
Yeah,
That's not even close
it's
to half.
incredible.
That's not even half.
No, exactly. So it's quite interesting to think of how long these things take to orbit. What I've also done here to explain what we're looking at is I've just switched the camera over to a live stack. So now what it's doing is it's taking an image and stacking it on top of the previous image. And what that does is it's supposed to, layer the light that's coming in to make a much, much brighter image. And in doing so, we reveal the moons of Uranus here.
Ah.
Which, yeah.
How many moons does it have? How many moons does it have?
Boy, it has about 25 or something.
Oh, okay. That's more than what I expected. I thought it would have like maybe 2 or 3 like Mars. Mars has 2 and we have
Yeah.
1. But I guess you know what? I'm noticing that all the gas giants have a lot of moons. Like Jupiter has like about 95 or more. We keep discovering more and more.
More and more, yeah. And Saturn has like 670 or something. And it's super, super crazy. But that's interesting. Why there's a lot of moons around gas giants and not around the terrestrial worlds. Something to ponder.
For sure. Maybe the moderators would know, or someone in the chat would know if there is a clear answer.
Mm-hmm.
But it would be interesting to know. Yeah. Would you, if you were to pick a planet to go and live, which one would you pick? Other than Earth.
Planet to go and live?
Assuming we can handle any extreme condition. Let's just say we are very adaptable creatures that we can live on any planet if we choose to. So which one would you pick?
I would live on a habitable space station or moon orbiting Saturn. I would love to see Saturn in the night sky.
Ooh, like close up.
That would be, yeah, just a nice close up, a nice bright Saturn in the sky, just kind of looming there. That would be really, really cool to see. How about yourself?
It's between Mars and Saturn actually as well. Just for me, Mars, because pink is my favorite color, so I want to see what it's like living under pink skies and blue sunrises or sunsets as well. Because with Mars, also we have pink sky. They have pink skies, but the sunrise sunsets are blue, which is kind of the opposite what we have it here on Earth. So it's in between Saturn and Mars, and also with Saturn, I just thought it would be very cool to live with, like, to be in a planet that has rings. I feel like that would be very, that would just change our perspective, being in a planet with rings and many, many moons. Like imagine like you're in a planet, because we only see one moon on Earth, but then on Saturn you see tons of moons just going around. I feel just the life would be so different.
It would be totally. Holy smokes. And this is the other cool thing. And it reminds me of a movie. Xena, did you ever see a movie called Ad Astra with Brad Pitt? Where he had to go out to Neptune, I think it was.
Oh my God. I think long time ago. Oh.
I forget when it came out, but
a long time ago. I feel like I need to go back and rewatch it.
Yeah. Well, the thing that made me think of that is that because he's out in this space station, he's doing stuff out at Neptune, but the entire, because Neptune is blue, the whole like cinematography of the movie was very blue. Which was so disorienting, just seeing blue everywhere where there was a window. It was just blue light coming in. And it just freaked me out where I'm going, I don't know if I could live near a planet that, is just blue and it's just showering the station and different colored light. That's what really stood out to me in that movie. If anyone's seen that movie, maybe they might agree or disagree. But that was crazy seeing that.
Oh, I'm sure. I think that's very mind blowing. I don't know. I guess like even more blue than more blue than Earth. That's and it's a nice blue too. Like it's not. It's like a very nice blue. It's a nice blue color. I don't know. I don't know. Maybe some people would agree or not. So hey, we
Well,
switched to Jupiter. I didn't realize you were
look at
switching to
that.
Jupiter. That looks
This
nice.
It looks all right. Now, again, the fuzziness is coming from our atmosphere. But I'm just kind of playing around with the settings here, seeing what works, what doesn't work. But maybe some of you might have said Jupiter would be a good planet to live around and enjoy. That's certainly what the Juno spacecraft is doing these wide elliptical orbits around Jupiter to take beautiful pictures and take brilliant data regarding regarding Jupiter's atmosphere.
Yeah, it's you know what I was always curious about? So Jupiter is the oldest planet in our solar system. And me having a degree, my major was in biology. I always thought with evolution, I I would have imagined that there would be species evolving or somehow being created on Jupiter, since it's one of the oldest planets, so it had so much time.
Ooh.
But I guess for us, we never really discovered any creatures or aliens on Jupiter. And it is 90% hydrogen and 10% helium. So I wonder if that has anything to do with that. That it's mostly those two chemicals, hydrogen and helium, but mainly hydrogen.
Yeah,
believe,
maybe.
I believe it has to do with the immense pressure along with completely unlivable, uninhabitable living conditions on the quote-unquote surface of Jupiter. Because there is actually no physical surface unless you count the core, where we theorize there's a metal-ish core in the planet. However, it is not habitable for life, unfortunately.
Oh, what are you saying? You can't handle like the 300-mile-an-hour winds on Jupiter or something?
You know, funny enough, it's not the winds that concern me. It's the fact that at one point the pressure and everything becomes so great you can no longer fall into the planet because the gas would become so buoyant and dense that you would actually float in place.
That would feel nice.
Well, that's what we theorize, anyways. I don't know how true it is because you can't really check.
Mm-hmm.
Well, when I was thinking about just in terms of creatures, it doesn't have to be like creatures on Earth. It would be whatever the Jupiterians kind of creatures. However they would be. So they would have to be living among hydrogen or living off hydrogen. I guess we just couldn't really discover that.
The Jupiterians, I like that.
Yeah.
But no, okay, that's a great point that Malcolm said, though, is how pressure changes based on how deep you go into something. Because it's gas in the atmosphere, of course, of Jupiter. But the farther down you go, the deeper into a gas giant, there's more and more atmosphere on top of you, putting pressure on you, right? So what happens is you'll eventually reach a point where there's so much atmosphere that's crushing the molecules of Jupiter that it condenses those gases into a liquid. So you have this liquid gas, quote unquote, that forms this layer. And then you keep going. You keep going into Jupiter, And you eventually get to a place where all of the weight of the atmosphere and the liquid crushes the liquid into a solid. And this is where where this solid core might come into play in these gas giants. In fact, this is crazy. This is actually how ice skates work, where water ice is actually less dense than liquid water. And that's why ice floats in your drink, is because ice is less dense. But what ice skates do is you're not actually slipping on the ice. The ice skates are compressing the ice underneath it into a liquid, and you slide along that liquid
Wow,
in an ice
very nice.
rink. It's super, super crazy. And also, it's okay. All the chemistry people that are in chat right now are probably gushing over this fact as well. Is ice is so weird that its solid form is less dense than its liquid form. Because
Yes.
every other material, its solid form is more dense than its liquid form. So, yeah.
That is weird.
Another reason why water is so cool.
It is. It's what created life, or at least that's how it's associated with life. Maybe it's
And
because of its unique quality or chemistry.
Yeah, it's so cool. And okay, speaking of water, or to bridge the topic, so I just increased the exposure time of the program here, and here we have a nice bright Jupiter, and here we see the lovely 4 Galilean moons. One of them, Europa, is a moon that's enveloped in ice and is strong. There's strong evidence that there is a liquid ocean underneath its surface. Water underneath the surface of one of its moons. So it's very, very tempting for missions to go.
Oh, you know what? So just thinking about what you were saying, living on you say you want to live on a station but orbiting Saturn. So that would be actually cool if, oh my God, if we were to live on a moon instead. So living instead of going, because I was thinking the planets, but now I'm thinking, oh, if we were to live on a moon of Jupiter, but then we are orbiting Jupiter. Imagine that. So you're living on the moon and you're orbiting Jupiter. That would, or orbiting a planet. That perspective would be very different.
It sounds like it's Pandora, but in our solar system.
Yes, Pandora
From
in our solar
Avatar, yeah.
system. Yes, that's right.
Mhm.
That's a good movie.
That is a good movie. It was a good movie. I liked it. Okay. So yes, nice, beautiful moons of Jupiter, and I'll just dim the exposure time one more time, just to give us a nice view of those brilliant equatorial bands.
Nice.
Love it so much. Now, let's think bigger. Let's see where we're going next. This is where we're going to go back to that nebula.
Ooh, where are we going to travel?
Let's try. Oops. Just let me type. No, it doesn't work. The Orion Nebula. Let's have a look.
Nice. In the Orion constellation.
In the Orion constellation. So here we go. This is another naked eye object.
Yes, it is.
Here.
Even though with the light pollution it's hard to see, but definitely the ancient astronomers were able to see it clearly with the naked eyes. Those were the times where you get to see
Those were the
things with the
days.
naked eyes. But hey, you know what? At
Um,
least we're not living inside a globular cluster because we would not see any night sky.
really?
Because well, I would think if you were living inside a globular cluster, there's several stars around, so it's probably going to be daytime all the time.
Yep, that's pretty accurate actually. We wouldn't really have much of any nighttime whatsoever. It would almost entirely just be a perpetual daytime from how bright all the stars are around us.
Yup. Unless we were different kind of species that could see through the daytime, like if we have we see it under a different electromagnetic spectrum. Look at that. Look how
This is looking beautiful.
I know because
I don't want to do that.
it's cold and it's clear, which is that's the perfect weather conditions for astrophotography. The air is more crisp and it's not as, there's not much, it's not as moist. It's it's how you want it.
Holy smokes. Okay, this is looking brilliant. Now, what I'm going to do, okay. It's very, very overexposed in the center here. That's because of the 4 stars called the trapezium that's in the center of the Orion Nebula. So I'm going to turn down the exposure time, and let's see if that fixes it. Do you want to talk about the nebula for a bit as I figure this out?
Absolutely, yeah. So Orion Nebula. Just to backtrack, so there are 2 types of nebulas. There is a stellar nebula and a planetary nebula. So stellar nebula, just from the name suggests, it's a place where stars are being born. And the planetary nebula is where a star near the end, it's before it changes fate, it goes through what's called a planetary nebula. And the name planetary, it was given that name because the astronomers, when they looked at nebulas, planetary nebulas, they thought it was round and it looks like a planet. So that's why they called it planetary. But this one, the Orion Nebula, because it has a weird shape, or it just doesn't have a distinctive shape, it's not round, and it's red in color or red pinkish in color. So it's a stellar nebula or a star birth nebula. It's the place where the stars are being born. And the colors kind of gives an indication whether it's planetary or stellar, because all the chemicals in the universe, they produce when they are excited, the chemicals, they produce a very specific color. So the color of hydrogen tends to be red, and all the stars, when they're born, they all start with hydrogen. So every stars in the universe is made of hydrogen. And then after it fuses and consumes the hydrogen, it goes to the next element, which is helium, and then carbon, and so on. So whenever you see red or pinkish color in the nebula, it means it's hydrogen. It indicates that there's a lot of hydrogen element in there. And eventually all that hydrogen will be used to create a star. So that's part of spectroscopy, or the term spectroscopy, where spectroscopy is it's a method where we would study light. So spectroscopy is the study of light. That's the fancy term for it.
Nice. And as you can see, I was playing around with it. Let me just. Oh, okay, never mind. I'm still playing around with it.
It's very pretty.
Go back up.
And I guess so with nebulas, they actually don't at least that particular nebula. So the nebula itself doesn't really produce its own light. It's actually what's exciting those hydrogens, and hence we can see the color, the pink or red color. It's the stars that Kyle just mentioned, the trapezium. So those stars are the one illuminated or exciting the hydrogen, and as a result, we get to see its color, its beautiful color.
There we go. Yeah, that's looking a little bit better. Yeah, and even you can see. Oops. Okay, hold on. I'm sorry. I'm still playing around with it a bit. It's because of the still overexposure of the center. Okay, that's looking a little better. Okay. Pretty close.
Yeah.
Um,
That nebula is about, I believe, 1,300, like 1,300 light years away, just from my memory.
yeah.
And that is the that nebula is the closest one to Earth, like a stellar nebula, the closest stellar nebula to Earth.
Yes.
if you
And
were
one
to-
that you can, yeah.
Oh no,
Sorry.
go ahead.
One you can see with the naked eye. It looks
Yeah.
like a very light cloud in the center.
Yes, it's a fuzzy cloud you can see. You won't see the colors. So that's like, maybe that's the some people may not realize, is that if you were to see it with your with the telescope yourself, you won't really see the colors because our eyes are not made that way. Like, while through the camera, because it's been exposed, I guess because the exposure is longer, and also we can collect more light, and then it can be processed in the camera. That's why we can see the colors.
Okay, this is looking not bad. Now that I've kind of dimmed it just a little bit.
It's gorgeous.
This is also brilliant. I haven't seen the Orion Nebula using this camera before, and this looks amazing. Okay, what I'm going to do is I'm just going to bring the light level down here just to illustrate kind of the 4 stars at the center there. So that's the trapezium. They are very, very bright stars that reflect, or the nebula reflects the light from the Orion, or from the stars, reflects the light to us, which allows us to see the nebula in the first place. But I just dimmed it a bit just to kind of show you. Now, if I can bring it back, give us that nice blue. Nice.
Mm-hmm. So I guess, since you mentioned the fun quote fact about twinkling stars, or the fact that stars don't twinkle,
Mhm.
if you were to go to travel to those nebulas, you don't actually get to see the nebula. So you don't actually get to see the nebulas, that nebulosity around you. You can only see it from very, very far away. So that fact
Mhm.
really kind of disappointed. It was disappointing for me to find out. So, but
Yeah,
also got me thinking that maybe we are living inside a nebula. So if there is a civilization that's, let's say, they live in the Orion Nebula and they're looking towards us, maybe they're seeing us living inside a nebula.
maybe. Yeah, maybe.
But yeah,
Definitely great things to ponder.
it just makes me think about all those space movies where they're like traveling and like in a spaceship, and they're going through a nebula, or they're seeing the nebula, when in fact that you don't get to see it when you're close to it. You don't get to see yourself inside the nebula, just because how dispersed all these chemicals are.
Mm-hmm. Holy.
I think it
We
looks.
got the boss taking over.
Now it's gone. I think this looks good. I think this is really good.
We want the quality. Trottier
That's good.
Observatory.
That's good, Kyle. Just keep that. That's good.
Okay.
Don't. It looks good. This is actually pretty good.
I want perfection, though. It must be perfect.
Oh, come on. No one. You can just keep editing nonstop, and you'll never be satisfied. You just have to reach a point where you just accept it.
Fair enough.
That's what I learned. If you were to use people who use Fix Insight, I remember Howard was saying that sometimes you just keep going in a circle nonstop, and it's just with editing the photos because you just want that perfection, or you just
Yeah.
get so engrossed into it. You just want to make it perfect.
And then
But
it's never done.
it's never over. That's why you could be spending hundreds of hours just editing one photo.
Hmm.
And that's normal in astrophotography, like spending all those hours. When I tell people like we could be spending like 80 to over 100 hours just editing one photo or one like just
Crazy.
focusing on one celestial object. That's what I meant.
Crazy.
Yeah.
Oh,
Are dedicated.
holy smokes. Hmm. Also, moderators, if there's any questions you want to relay over to us, we're more than welcome to answer them. Yeah, again, unfortunately, I don't have the chat open with me at the moment, so I'm unable to see any questions. But let us know anyway, because we love questions. We love hearing from you guys and your ponderings. I'm just
That
gonna
is beautiful. Like I am really
Yeah.
enjoying this nebula.
I'm just gonna brighten it again because I just want to see the outer structures here. That looks great.
I wish someone, whoever, is it you, Malcolm? You should screenshot this photo.
All right, hold on.
Oh,
Screenshot it. This is so pretty, and share it with us.
hmm.
Since how often we get a clear night, a very clear night on a cold night.
Yeah, that's the thing. Okay, so once again, with the atmosphere and all that, if it's hot, that means there's going to be more like heat waves in the sky than usual, which means there's more distortion in the light that's coming through. So astronomers love cold and we love dark.
Yes, that means we don't like the moon, which is
Yeah.
interesting. Because moon is also like people who love the moon is all about the romance and it's poetic. But actually, astronomers, they really don't like the moon. Maybe you can tell them why, Kyle. Why don't we like the moon?
Well, it's so bright that it glares out a lot of the pretty deep sky objects that happen to be in the sky, which is really unfortunate. However, I will give the moon credit that you've kept our tides in motion for billions of years, giving life a chance, and we thank you to the moon for that. But just turn down the light a bit, and then we're good.
Yeah. So it's probably good we don't live on Mars. I'm assuming because it has two moons. So I would assume maybe
Well,
not necessarily.
the moons on Mars are more like captured asteroids. But
Sorry, I accidentally unmuted my computer.
oh, okay, fair enough. Yeah, sorry. So the moons of Mars are actually captured asteroids. So they're much smaller than our moon. So they won't really cause any kind of great distortions or glare or anything. But
it won't wash out the targets. If we were to look at a nebula, it won't wash it out as much as
it
our
depends.
moon does.
It depends.
Yeah, I
Oh
suppose.
my gosh. I suppose. Malcolm, can you try typing? I'm sorry, my friend.
I will try. It's actually it's not your fault. There's a bit of a weird problem that this has. I don't know why, but yeah, as you see there, like I think the
what the heck?
function or one of the keys is like being forced down. I don't know why. I don't know why it is.
Oh, weird.
But
Okay.
it is. Yeah. So unfortunately, we can do that.
Just typing in the name usually gets us, yeah.
Yeah, I think it's that one. And then we can just go straight to it.
Ooh, Nice. Okay. I'll just do that. And this is the clearing game.
Beautiful picture,
Now we
just
just-
pink.
Oh, love it. We love
You
pink.
screenshotted it?
Yes, I did screenshot it.
Oh,
it's
beautiful.
'cause
Please
it's
send it to us
sorry.
later.
Turn it back to 20 seconds, and then we go like this. Now we wait.
I think we're still moving.
Yeah, we're not even there yet. There we go. Okay.
Good news is we're in the right place, though.
Oh,
Nice.
you're welcome. There, someone asked a really good question
Hmm?
in the in the chat.
Oh.
Yes, that's actually a very good question about whether or not we have stardust in us. So everything that we're made of, all elements come, like all the higher level elements come from stars. In fact, the heaviest elements, the really, really heavy ones, all come usually from supernova, like really heavy stuff. But yes, so all of us are made from stars. Our Earth would have formed similar time to when our star was being formed. And as a result, our Earth kind of came in, and all that stuff that star is made out of is what our Earth is made out of. It's what we're made out of. So everything is really just star remnants. So yes,
Yes.
you're a star. Congratulations.
Not a star, superstar, because we originate from a supernova. So we are superstar
Ooh.
or superstars dust. That's what I tell my students.
Love it.
I tell them they're superstars.
Super Stardust.
I'm just looking at
Um,
our view here, and I'm not seeing.
me neither.
I'm not seeing
Where are
a
you guys
galaxy.
going? Where
We're
did
on
you
boats.
go? Where did
We're
you
on
travel?
boats. We are on M81 Bode's Galaxy. Or we should be.
That does not look like a galaxy.
That's stars.
I thought you were looking at a cluster.
It looks like a cluster. Yeah, it does kind of look like a cluster, doesn't it?
Yeah, and the boat does not look like that at all.
No.
Why don't you try M82? Try the Cigar Galaxy, and then from
Yeah.
there we can go to the boat.
Oh, whoops. Um,
Someone asked, why is since Jupiter is mostly made of hydrogen, why isn't it a star?
It's a failed star.
ooh.
So we define stars. Something is classified as a star when at the core there is fusion, nuclear fusion. So that's when hydrogen and the very badly explained version and totally incorrect version is when you have hydrogen and hydrogen fusing to become helium. Now I skipped a lot of steps there, but that's when a star becomes a star, is when it's powered by its own fusion at the center. Jupiter, at its core, does not have hydrogen fusion. Now, it almost did. It's almost big enough. But as a result of the fact that it doesn't actually have that, we call it a failed star.
Yeah, there you go. Exactly. It doesn't power. It doesn't power. It doesn't have nuclear fusion. It's not a nuclear reactor.
Yes. Our star is. Our star actually has fusion going on in the center of it.
Mm-hmm. Look at that. It's so pretty.
Look at this. Look at this.
Look at that cigar.
Okay. I'll just dim it here just to illustrate an important feature, that this Cigar Galaxy also has, I would guess, an arm or some sort of dust material that's occluding the main disk here, which you can see a little bit if I just make it normal again. But this is a galaxy that we're seeing edge on. So if you imagine a galaxy, just like a dinner plate, where if you orient the dinner plate face on to our eyes, and we can see the nice shape. You can even draw a picture of a galaxy of its nice spiral arms if you want and paste it on the dinner plate. But there are some galaxies that are oriented that we are looking at its edge, and we are not able to see any kind of structure or significant structure, I should say.
Yeah,
Which is
I actually like this on Galaxy. They look, I don't know, because I'm always used to looking at the galaxies from the top view or bottom view, and I rarely see galaxies that are edge on. So for some reason, I really enjoy looking at edge on galaxies because you get to see it's like a different perspective to it or a different side, you know? And you get to see those jets. Because we don't see it here. We don't see it in this. Like, we don't see it with our telescope. But if you were to look at the fancy NASA photos, you get to see the jets coming out from the center, which we don't get to see that if we were looking at the galaxy from the top view.
I wonder if that's part of this kind of central structure that's going across here. Like it's little jets or something.
I think so, yeah. I mean, honestly, I would have not known if I haven't seen the NASA photos, but when I compare them, it looks like, yes, you can kind of see it. But if you haven't seen the NASA photo, I don't think people would know to look for it.
Yeah. One other thing, and I'm sure the moderators are on it in the chat, but the distance to this galaxy is something really, really incredible. I'm going to take a guess, and then the moderators can fact check me. Okay, is it around 15, 20 million light years away?
You're a little high. You're a little high. Go a little down.
A little down. 10.
A little bit too low now.
Too low. Okay. So somewhere around 12 or 13?
12, yes. That is what NASA says. And I trust NASA.
12. Oh, you almost got it. You got the average, Kyle.
Okay.
There's a galaxy right beside it, actually, which is really close. And I'm pretty sure they're actually interacting with each other. That's how close they are. I believe they are, anyways.
Interacting, as in merging?
I'm not going to say yes or no to that because I don't know enough to say yes or no to that. If Beatrix, if you want to check that and put it in the chat, that would be perfect.
Because if they are, a fun fact for people to know is that our Milky Way, where we live on, the galaxy we live on, is going to merge with Andromeda, our neighbor galaxy. That's only 2.5 million light years away.
Yeah.
And we're getting closer and closer and closer by the minute. And I heard that, and I haven't heard. I've learned that actually when we merge, it's not really going to affect us as much. But our night sky would look so different. And I'm pretty sure there are some artist illustration that you can look up how our night sky would look like if the merge or when the merge happens. But I'm pretty sure it will be very, very spectacular.
Okay, I did Google it really quickly. Sorry, but M81 and M82 are interacting. Oh, Joanna just put it in the chat. Never mind.
Okay.
Yeah, no, they're interacting, and it's causing some starburst activity.
Ooh, that's exciting.
Yeah.
Ooh, cool.
Thank you, Beatrix.
Thank you. Yeah.
Question. With galaxies, because we categorize galaxies depending on their age and potentially their shape. With edge on, how do we know what type of galaxy it is? Because Milky Way is a spiral galaxy, and it's kind of the middle age. And then we have the irregular galaxy; those are the young ones. And I think the oldest ones are the elliptical. And you can tell from the colors of the stars. That's how they're indicative of their age. So the elliptical galaxy will have mostly red supergiants and red giants. So the red stars, yellow stars, while the irregular, which are the youngest, because they have mostly blue stars, and your spirals are the ones in the middle. They have a mix of both stars.
It's actually funny. It's funny you mentioned that, because ironically, a lot of galaxies that are spiral galaxies are actually similar in age to ellipticals, which is kind of weird because, as you said, the blue stars, the star-forming galaxies, spiral galaxies, are what we'd expect to be young, while ellipticals, which are what we call red and dead, we expect them to be old because a lot of their stars aren't blue. They're the small stars. They're like our sun, for example, which age to much, much larger values in the billions of years old, as opposed to blue, which only go into the hundreds of millions or tens of millions. So it's kind of weird because you see ellipticals, which are filled with these red stars and aren't really star forming anymore, but they can sometimes have a very similar age to spiral galaxies like ours, which is kind of weird.
Just a glimpse into what's going on in the astronomy community right now, on what is being researched and what are the questions that are being asked at the moment.
Yeah.
Really, really cool.
Well, do you guys know, how can they tell, like from the edge on galaxy, how can they tell what type of galaxy it is? Like, is Cigar Galaxy an elliptical or is it a spiral?
I think it has to do with the actual shape, and that you can actually see structure for the arms. The fact that it's flat like a disc as opposed to the actual elliptical, which is, well, elliptical and very, well, I'm not going to say spherical, it's elliptical in shape. And I think that's part of it. You can actually see the structure of the arms from the side, which, in fact, in our picture right now, in our view right now, you can see structure of the arms that would look similar to our own galaxy. Now, I can't speak on behalf of this because I don't know, but I'm assuming there's also kinematics we can see, or physics we can like measure about Bode's galaxy, or sorry, the Cigar Galaxy, that would only match that of a spiral galaxy and wouldn't match what we'd expect from a elliptical galaxy.
So this would be going into spectroscopy again, looking at the Doppler shift of some of these stars, maybe?
Yes. Yeah. That would be something we could do to view that, is we could look at Doppler. So we could look at the effects. It has to do with redshift and a bunch of other spectroscopy things. It's a bunch of physics mumbo jumbo. Yeah. But yes, thank you, Kyle. That is correct. It's
I would say it's one of the weirdest things, like the Doppler effect. That's just weird.
It is, yeah.
It's a very weird concept, but also very, very cool, I would say.
Yes. So,
like how the stars change color with respect to us, to our our point of view.
So it's just like how when you hear an ambulance or a car horn coming towards you, it sounds like it's a higher pitch than when it's going away from you, which has a lower pitch. Same thing happens with light, where high energy light becomes blue and low energy light becomes red. Kind of like the common analogy that's used is like a duck swimming away in a pond, where the waves in front of this duck are scrunched and close together, and the waves behind the duck are much more spread apart. Same thing that's happening with light and stars, which is how we can figure out how fast these stars are moving in space. So, but just to kind of circle back to the point that we're making of how we think this is a spiral galaxy, is if we point our telescopes to one side of the galaxy and notice that a lot, or even all, of the stars are blue in nature, that means that the stars are moving towards us. And if we go to the other side, and if most or all of the stars are more red in color, that means that the stars are moving away. So we can tell that this thing is spinning to some extent.
Like a spiral.
Spiral.
Yeah,
voila.
just like a spiral.
You get a spiral.
That's crazy. That's just crazy.
Awesome.
The stars change color, whether it's moving away or moving towards us. So if the star's moving away from us, we see it's more red, and then if it's moving towards us, it's more blue. That's just mind blowing.
Holy. Okay. I'm just being aware of the time. I'm gonna move it to just.
Oh my God! It's already time.
It's pretty close. Holy smokes. I am going to move it to just a cluster that I know is sure to wow everybody. Well,
we can't do Hercules, unfortunately. Hercules is actually below the
oh my
horizon
gosh,
right now.
it's set. It's winter. Oh my gosh. Okay.
So unfortunately,
this is habit.
We can't do that.
Okay, then let's try this one. Let's see. Let's see. Sorry, force of habit. I'm always used to going to Hercules, and it's like, oh, it's so cool. This is nice and dense cluster. Anyway.
Okay. How about we do M1, the Crab Nebula?
Ooh, that's a little tricky to find with the telescope.
Fair enough. No, it doesn't. That was just a suggestion. Or
no, all good. Yeah.
Dumbbell.
Ooh, dumbbell would be cool. I just want to see how this cluster will look like through.
Which one? The clown face?
No, the Christmas tree.
Oh yes, I forgot about that one. Yes, that's Christmas. Maybe we'll see the nebula. I don't know.
Ooh.
So that showed up. So that's a new nebula, and maybe people might wonder, is like, how come we've never seen it before? Why are we seeing it right now? And the answer is that it's in the light, because the light just got here. That's why we're seeing it now. So before that, the light hasn't reached us yet. That's why we didn't see it. Because the only way for us to see any star or any object is just the light, is from the light that we receive from that star or from the area in space. So that's so if we're looking at the Christmas tree cluster or the nebula, we'll see if we can see it. So that one, I believe, is about 2,000 light years away. And
the Christmas tree?
Yes, and it's an open cluster. That means it's a young star. They're probably filled of the blue stars, and blue stars are young and very hot. Which kind of makes sense that we've never seen it before, so they're newly born.
Yeah, I'm seeing lots of blue for sure from these from the stars here, so that's a good sign.
Oh, there's one that's very bright, right? In that, I guess maybe it's overly exposed, or is it just a very bright star?
A little bit. This could be a foreground star, in the sense that it's a star that's just really, really close to Earth and just happens to be in the way of looking at an object. So, which is why we see all these diffraction spikes here. So
nice, makes sense.
Oh, Christmas tree. Well, I mean, I guess it's got a little triangle going on here.
I'm sorry,
yeah,
Kyle.
I see it.
You're about a couple weeks late.
Oh yeah, because it's not Christmas anymore. It's the Happy New Year cluster.
There you go.
I'm 2 weeks late. But this star, that would be so perfect. If this star was like right here, that would be really cool. Then it would look like
I was thinking just, when you put the actual star on the Christmas tree, and I was thinking maybe we're looking at it from the top view, just that one in the middle that's super bright.
Oh, like this is the base of the Christmas tree right here, and then this is the top. Could be, yeah. Could be a different orientation.
Absolutely.
Yeah.
So actually, I did a little digging on my own, and I checked NASA's website on the Christmas tree cluster. It's quite green.
Green.
If you can actually see the nebulosity, it is quite green from their photo, and it does somewhat resemble a Christmas tree. I can see where they're coming from with that. It does have that triangular shape of
Huh.
a Christmas tree. So yes, that would be why. Unfortunately, we can't really see that right now.
No, yeah, the nebulosity is still
Why
pretty,
can we not
pretty
see
dim.
the nebula?
Probably because the very bright star in the way. That would probably
Yeah,
be
probably
causing
this.
it. As well as the fact that we don't have Hubble or the JWST, and we have a lot of light pollution. A lot of light pollution, considering
Yes, I know.
the campus is under construction everywhere.
Mm-hmm.
I see.
Fair enough.
Oh my God, 1 minute left.
Yeah. Well, just to wrap up, folks. So we went on a really great cosmic journey looking at something as simple as a supergiant star, Betelgeuse, and even our own neighbors, Jupiter and Uranus. We went all the way to Pleiades, a nebula, the Orion Nebula, and also we got to look at an awesome Cigar Galaxy. Pretty cool. Finishing off with a nice open cluster, the Christmas tree, or the Happy New Year.
Yes. Happy
From
New
here.
Year. Happy holidays to everyone.
Yeah. And thank you so much for understanding that we didn't do it in person. Just that cold snap really caught us off guard. So we hope you enjoyed the show from your nice, cozy homes with perhaps a nice cup of tea
Yes.
or something.
I know I
but for-
have.
Oh yeah.
Like I have
know, like,
my Earl Grey latte.
Oh,
But the hot
I got a
chocolate
nice
would have been
candlelight.
fitting as well.
But yes, so just looking at the time, from all of us here at the Trottier Observatory, thank you for joining us and enjoy the rest of your night.
Good night, everybody. And
Good
see
night.
you
Good night,
potentially
everyone.
next Friday.
See you potentially next Friday.
Or and on a Friday night.